I hope we are live right at the moment. Good evening, everybody who are watching at this moment on the other side of screens. Hello, I'm very glad to welcome you on 289 meeting of Warsaw Java user group online this time, and we are very happy to. Oh God, give me a second. Okay, sorry about that. I had the YouTube open in the background. All right, we are very happy to host today Michał and Martin from Red Hat and their Quarkus World Tour. This is a major tour. I saw multiple dozens to really events around the globe about the Quarkus. But before we Michał and Martin could take our virtual stage, we want to thank our partners, JetBrains. We have licenses from them, Decerto. We have books from them, and Stacja IT. We have the workshop, one-day workshops about multiple things around security development and so on. So please be active, ask questions, and those prizes can be yours today. About Q&A session, if there is a question about the topic that Michał will be talking at the moment and it's relevant and good to ask on the spot, I'll try to ask it in the same moment, but the Q&A session will be at the very end of the presentation. So if you have the questions, more general questions about Quarkus, please leave them for the very last time of the presentation. But if there is a question about something that Michał is talking at the moment, please ask it right away on our chat. This time I will also want to ask you to those who are not yet there to be invited on the JVM Poland Slack channels. There's lots of great discussion, news from all around the world of Java community. So if you're not there yet, please join us. And I think that's everything from our side. So thank you very much, Michał. Thank you very much, Martin, to be with us here today. And please, our virtual stage is yours. Have fun.
So, hi again. My name is Michał Szynkiewicz. I'm here today with Martin Koba. We are both from the Quarkus team at Red Hat. And we are here today with the Quarkus World Tour. Quarkus World Tour is an initiative to interact with Java community and to spread the word on Quarkus, since we cannot do conferences. If you'd like to invite Quarkus team to your JUG, there will be a link to that somewhere at the end of the presentation. So the agenda for today's meeting is simple. First, I will show a few slides mixed with a demo. Then we will switch to a Q&A session when Martin and I will try to answer more general questions. So what is Quarkus? So Quarkus is a Java full stack framework, so something like Spring Boot or Micronaut. The catchphrase for Quarkus is supersonic subatomic Java. This reveals two major focuses of Quarkus, so speed in terms of startup speed, but not only, and low memory consumption. And another major focus of Quarkus is developer joy, so developer experience. So the supersonic speed and subatomic size sound nice, but what does it really mean? So as you will notice if you take a deeper look at this picture, a simple Quarkus application running on a JVM can start and handle the first request in less than a second, using a bit over 70 megabytes of RAM. This RSS shows the total memory used by the process. This may sound like a lot, but if you try this with the most commonly used Java full stack framework, you will use nearly twice as much. But JVM is not the only way Quarkus applications can be run. One of the biggest features of Quarkus is that it lets you seamlessly move from JVM to a natively compiled binary. It's just a matter of adding a property to your build. So when this simple application that we tested was compiled to a native binary, it could start and handle the first request in not much more than 10 milliseconds, using slightly over 10 megabytes of RAM. Yeah, so this numbers obviously increase if you add more features to your application, but even REST plus Hibernate, it still starts within tens of milliseconds. Okay, so yeah, as I mentioned, even in the JVM mode, we are much faster than the standard things that are used. And you could wonder what's the reason for the JVM gains. So feature-wise, the tested Quarkus extensions for the tested application was the same as the Spring Boot ones for the traditional stack. So the reason for the gains is that traditionally in Java, building an application with Maven or Gradle simply means packaging all of its elements and potentially dependencies into a jar or war. Then at startup, such an application loads the configuration, scans the class path for annotations, does dependency injection, etc., and then starts. So in Quarkus, it's a bit different. Quarkus during the build time looks for annotations, sets up stuff based on configuration, prepares dependency injection, and like from this information, Quarkus generates classes that are packaged together with the application, and then this is used on startup just to not to have to do all the setup work on startup. This limits the work that has to be done on startup, but also limits the amount of classes that have to be loaded, and even limits the amount of dependencies that we need at runtime, right? I see there are some comments already. So what is full stack? I don't know. So another name that I sometimes use for Quarkus is an application generator. Yeah, I don't know. Anyway, I'll continue with the slides and we can try to figure it out at the end. This model, Grpc fits, or if I'm being honest, was inspired by what's needed. So this fits how applications are compiled natively with GraalVM. So GraalVM during the native compilation compiles stuff ahead of time and ahead of time analyzes the code. So because of that, dynamic features of Java such as dynamic class loading are not supported. Some other features needs registration, like reflections, for example. So with Quarkus, with this model, if you stick to supported extensions and add dependencies that don't work on reflections, etc., you can compile your application to both a jar file or a native binary. So yeah, we gain a lot when we compile to a native binary. So you may wonder if this is a silver bullet, if this is something I should use for everything then, and no. So if you're after startup time, so for example, fast scaling, or low memory footprint, which means cost reduction if you don't do CPU intensive services, or small packaging, native binary is the way to go. If you are all about peak throughput for your service for a single instance, then like JVM with its just-in-time compiler can do better. And also max latency is better on the JVM. Monitoring and debugging tools are better for the JVM. Also, this picture shows developer joy as very low for the native binary, but it is also only for running it, right? With Quarkus, you can work locally with the JVM and then build a native binary and deploy a native binary to test or production, and it should behave the same. So, enough slides. Let's do some demo. Okay, so normally if you'd like to start working on a Quarkus service, you do go to code.quarkus.io, and then you select the extensions that you need. So I don't know, REACTIVE, JXP, or whatever, and you could generate an application. Sorry, light is killing me. Oh, better. But I want to use a very new version of Quarkus. The things I'm gonna show you, some of them are rather experimental. So I will use actually the main branch of Quarkus for my test. Sorry, for my demo. So let me generate an application for this. Yeah. So what I'm doing here is this lengthy command here. What it does, it calls a Quarkus Maven plugin, and it calls a create goal on it. This way I will generate an application similar to, well, actually identical to what I would get from code.quarkus.io, but this is for a version I selected. This is 999 snapshot. This is how we call the snapshot versions for Quarkus. And what I'm doing here is also I'm selecting platform artifact ID. If I remember, I'll tell you a bit more about it soon. And I'm also saying that I want to have REST-easy Jackson extension right away. And I'm setting project group ID, etc. here. So let me just run it and open it in IntelliJ. So there was a question about Spring Native. I don't know. I haven't tried it, but on one of the Quarkus Insight recently, there was a customer, or sorry, a user of Quarkus, who said they tried and to see how their application behaves with Spring Native and compared to Quarkus, and actually I think the Spring Native numbers for this specific application obviously was rather closer to Quarkus on JVM than Quarkus in the native mode. It's also at least last I checked, it was also much easier to work with Quarkus and native compilation. But yeah, I know Spring guys are working on it, so it's for sure it's changing for better on their side. Okay, so I have a project. If someone has problems viewing these letters, please let me know on the chat, and I'll increase the font. Okay. Let me just do one thing here. I'll add a lot of dependencies to my project, so I want IntelliJ to reload on my project on these changes so that I don't have to click reload. That's why I'm playing with the settings right now. Okay, so what I got is a Maven project. You can also do Gradle with Quarkus, but I'm a Maven guy,
Michał,
so use Maven.
Sorry to interrupt, but there is a request to increase a font a bit.
Okay.
Cool.
Thank you. So I'll do this here and in the editor as well. Okay, is it anywhere? There's also a question for expanding an import section. Okay, so what I got generated is a Maven project that has an example resource, and this is the imports here are from JUG, so Java EE actually, and yeah, this resource is exposed on hello and hello path, and it just has a single method, returns hello REST easy on a get query. Okay, So I'll show you if it works in a minute. But now this BOM file that I selected while generating the project is the property here, Quarkus platform artifact ID. Normally, when you work with Quarkus, you'd usually use Quarkus Universe BOM, which contains all the extensions that should work with Quarkus. If I'm using Quarkus BOM, it limits the number of extensions to the extensions that are available in the Quarkus core repository. That's because I'm using the repository from the main, so there's no like released version of the Quarkus Universe BOM, which is a separate project for this unreleased version of Quarkus. Below I just have some Quarkus extensions as dependencies. I have Quarkus REST Easy Jackson and Quarkus REST Easy. I can actually remove this one because Quarkus REST Easy Jackson depends on the other one, and I have test dependencies on JUnit 5, and rest assured I'll add stuff that I like here first, so that is easier for me to work later. So I'll add assert J and awaitility in the test scope. Okay, and I can go and try to do some coding. So first I'll just start my project with mvn quarkus dev. And so what I was showing you so far was already the same when I presented Quarkus 1.5 years earlier ago on the Warsaw JUG, but I thought the introduction is in place. So now the first new feature, really new feature. This is so new that it's not really stable yet, so this may fail at some point. Sorry for that, but I hope I think we will polish it for Quarkus 2.0 final, which should be released soon. So when you start your application in the Quarkus in the dev mode, Quarkus dev, you can obviously check if it works doing curl on localhost 8080 hello, but you can also press R in your console running Quarkus dev, and it will run your tests that you have defined here, because together with the generated project we also have a generated an example resource, and if I change anything here, the test will be re-executed, and if I change it back, it will be executed again. The same with the code here. Quarkus will figure out that something has changed, the test has to be rerun. Okay, so this allows us to do some TDD style of working, and I like to play a bit this way. So I'll do what I want to do is a to-do application, and I will show you how it look like. First, maybe I have some HTML prepared to show you that. So let me just go to localhost 8080. This will be what we're working on. We can add a to-do here. Actually, we will be able to add a to-do here because we don't have a backend yet, and we will be able to mark a to-do as done. So, as I mentioned, I'd like to work on it TDD style. So let me start with a test, and maybe I'll show you one more thing. So there's this Quarkus dev that you can run the tests in. So I now have application running from it, and I also have tests running in it. But I also can run the tests separately. So I can just do mvn quarkus test, and now I will have this console only showing results for the tests. Okay, so let's get to the oops, not this one. Should add to do. So let's get to the tests. Not to bore you to that with coding everything live. I've cheated with IntelliJ's live templates, so I just need to fix some commits. And oops, this one. So what I added here is I added a method that tests if we are able to add a to-do. This is just sending this JSON, posting it to to-dos, and assumes that the status code was 200 for it. And as you probably noticed here, as soon as I saved this test, I see it's failing with 402. So let me quickly implement the service. I'll start. I want my to-do to have title, description, state, and ID. So I'll start with the state. It will be an enum, and it will be new or done. I need some object to carry this information, so it's called a to-do DTO, and I'd like to have this fields here. Like I said, ID, title, description, and to-do state. So having this, I can jump to implementing the actual resource. So to-do resource. You know, Quark to-do resource. Okay, and let's make it application scope, and we want it to be on the path to-dos. And if someone does a post to it, oops, we do public to-do DTO, add to-do DTO, and for now, to pass the test, I can just simply do something like this, right? Oh, and I have first failure. Yeah, that's what I told you guys. Sorry. Yeah, the thing is that new that it is not very stable yet, but we're working on it. So after restart, the test is passing. Now we can do another thing. For example, listing to-dos. This test will just add a to-do again. That it will take an ID from the returned to-do, which we don't have it yet, so this will fail first, and then it will use get on to-dos to get a to-do list, and then we'll try to find the to-do with the given ID there and extract the to-do state from it and verify the to-do state is as expected, which is new. So let me, if I run the test, there's a null pointer exception here on the JSON path. So let me quickly add it. Okay, so we want this ID here, so we need to do ID, and I can just do private final atomic long, for example, and call it ID sequence. And here I can do ID sequence, get an increment to generate some ID. Also for a new ID, I like to set its state to new. I need to store it somehow to be able to get it. So let's do final map of ID to the to-do DTO. So let's call it the storage maybe. And store it in a concurrent hash map and just put it there. So storage, put DTO ID, DTO, and then the get will be really simple. It would just do return a collection of to-do DTOs, and let's call it get all, and then just return storage values, right? So let's see, I saved it works. There's one more thing that I'd like to add here, which is should mark to do done. So similar to what was before, now we are adding a to do about feeding the hamster, and there will be we are expecting that there will be a put exposed on to-dos, to-do/ID to be precise, and that it will return to 100, and that it will result in actually changing the state, because this is what we do here. We change the state to done. So let's quickly implement it. So let's do put path. So for implementing a REST service like this, I could actually use also Spring Web annotations. They get, during the build time, they get translated to JUG's REST annotations, more or less. So, sorry, update. and we want to have a path parameter called ID with the ID, and I do the DTO. So let's do storage, put DTO, sorry, ID DTO, and just return this DTO. Okay. So yeah, I added it. Let's see if the web page works. So again, can I add a to-do now? So you can do cat feed the cat. Whoops. What happened? Oh, okay. I have Quarkus test enabled, but I don't have the dev mode executed. So let me do Quarkus dev. Wrong directory. Sorry, guys. So ambient Quarkus dev, and I can just do here and add a feeding the cat to tools, and then say that it's done. So we have something, but it is not very practical. So, but with it, let me show you one more thing. So we have this to-do resource test that I wrote, and it tests Quarkus in the JVM version. And as we had this native greeting resource IT, we can have a similar test for the native to-do resource. So we can have native to-do resource IT, for example, and it's enough to extend the to-do resource test and annotate it with native image test to have this test. So the test methods in the to-do resource executed against the native binary. Okay. Oh, sorry, not to the resource, but to the resource test. So I'd like to actually show you how simple it is to build a native binary. So it's just a matter of adding the -d native property, and we will see some results in a minute. Okay, let me take a look at the chat if there are any questions to what I'm doing here. Okay, I didn't see anything. So I'm building the native binary. As you see, the normal tests were executed to make sure that we don't waste resources on the native build, and then the native build was triggered. It takes a lot of resources and a lot of time, so it's not really suitable to like work on with it locally, but it gives great gains in terms of resources. And now, as the native binary was built, we have the tests executed against it, and it is built. So now we can run our to-dos application with the binary version of our to-dos application. It started actually in 34 milliseconds. I'd say that's quite a lot for this simple application. This time differs obviously application by application, and it is also the results are different for different Java version, different GraalVM version. We are trying to keep an eye on it. Yeah, but I'd say this number is quite a lot. I mean, this is really low, like 34 milliseconds for starting an application, but I'd expect it to be even lower. So let's go to Quarkus localhost 8080, and we are now adding to-dos to the native application. Okay, and we have it. Marking it as done also works. Okay, so we have something that works. we have tests to prove it, but this doesn't really store the data, so every time we restart the application, our to-dos are forgotten forever. So let me add some stories to this. So the standard way to do it is to use Hibernate, probably. So let me add a Hibernate extension to my application. I can do it in a few ways. I can just add a dependency here. I can go to code Quarkus.io, find the extensions I'm interested in. So maybe I'll try it this way, for example. So I'm interested in Hibernate RM with Panache, for example. I can click here and copy a command to add it with Maven. So I can do this. This command is mvn quarkus add extension. Or I can, so what it really does is there's no magic in it. It just adds a dependency to the POM. I can also obviously run it by hand, add extension, and I will add JDBC Postgre extension to my application. As you can see, I only selected a typed in as a substring of the extension name, and Quarkus was able to figure out what it really was, what I really mean. And as you see, there is a Quarkus JDBC Postgres rail here. Okay, so let me maybe run mvn Quarkus dev once more. And there's one thing that I want to change for this part. I will add a property for Hibernate to drop and create the database schema on reload, so that I can add an entity. I could even modify it this way, but I won't do this. So let me add an entity here. So repository, maybe package, and to-do, repository. And let's add a to-do entity. So this is a JPA entity, so I just add entity on it, and I'll say that it extends Panache entity. And here I only need to add the fields that are really interesting. The ID is taken from a Panache entity. I will also get a few nice methods from it. So now let me implement a to-do repository that will handle saving, etc. for to-dos. I'll try to be fast on it, so let it be application scoped. And this repository should have an add method, or maybe it should return a to-do. Add to-do, and it should be transactional, of course, because we have to run it in a transaction. And so for this, it's enough to just do to-do.persist to-do. We don't have to inject an entity manager or anything like this. And let's return this to-do from this method. Another method that I like is something that will return a collection of to-dos. And actually, I will need to map these to-dos to to-do DTOs, so I'll just do stream right away. To-do get all. So for this, we have to-do stream all. We also have list all if we wanted a list. And let's add a method that would modify something. So public to-do modify. It will take a log ID and to-do. Maybe a method that modifies a to-do. So modification maybe all. And so we can do to-do find by ID to-do. This is actually of type to-do, and then we can do modification accept this to-do, and we can do just return the modified thing. Okay, so now what we need is to change the to-do resource to actually use this. But here we have to-do DTO, there we have to-do, we need to map one to another. Normally I could do something like mapstruct for it, but I'll just cheat and use live templates again for it. So let me just do mapper. Okay, I have some methods for mapping these things, and let me just remove this and inject the mapper, and let's inject also the repository. So to do repository. Okay, now I can in add I can just do repository add, and not the to do, but something that mapper does from this to do, right? So we map this DTO to an entity, and this is what I pass to repository. And as for get all, it's as simple as repository get all, and then let's map every item on it to DTO, and let's collect it list. Okay, and the last is update. Update is also simple. So modify ID, and then we will get some to do here, and this to do we can map with mapper. We can merge it with what we have this way, and we can just entity. We can just use mapper this way on it. Oh, so let's try it if it works. Wrong window, sorry, this one. Let's try to add a to-do. Cat, feed the cat. Okay, it worked. I don't know if you guys noticed what happened here, but I added Hibernate to my application. I added Postgres to my dependencies. I only said that I want to drop and create the database on restart, but I haven't configured any connection to a database. And it works. It stores stuff in a database. That's because Quarkus now comes with something that we call dev services. So when Quarkus figures out that for development or test you may need something like, for example, a database or a Kafka, then it can, and you have Docker running, then it can start a container with what you need, and configure in this case Hibernate to talk to the container that was just started. This also works test. So if I do mvn Quarkus test, the container should also be started. Okay, as you could see, the container was started here. Something was wrong. Should list to do's failed. Huh. That's interesting. I did something wrong here probably. So, oh, yeah, add just returns the DTO that comes in. And what I need to do is grab this entity that is returned, and then I need to map it again to DTO. And then when I save it, the tests are rerun, and all tests are passing now. And as you can see, it happened in less than a second. That's because in the continuous testing mode, the container is kept alive before it reloads. So it's much faster than if you'd do mvn test or whatever with setting up a container. So yeah. Let's get back to the slides for a moment. So yeah, we have new dev services now. So there's no need to set up a database or Kafka or anything like this for your local environment anymore. There's continuous testing for TDD-like work, which looks great, is really promising, but as you could see, it's not very stable yet. There's one more thing that I wanted to point out here, that this continuous testing is actually quite smart. So I had 4 tests in my application. I have 3 tests for to-dos, and 1, 2, 3, and 1 test for the greeting resource test. And Quarkus figured out that when I do anything with to-dos, only the 3 tests that are related to to-dos need to be rerun. So if I change the greeting resource to hello is easy with an exclamation mark and save this, Quarkus would only run the 1 test that is impacted by the change. If I roll it back, yeah, it got run again. It's like green again. Yeah, so there is this smart test reruns, and the container with the database or Kafka is not restarted if it's needed for the tests. Actually, I don't know how it's with Kafka, but for the database, it's definitely not. And we have 0 restart work with the dev mode, right? And also, I don't know if you noticed, but with rest assured here, there's no configuration whatsoever that would say that rest assured needs to talk with Quarkus on port 8081 or something like this. It's all done automatically by Quarkus. Okay, so what if I need better performance? This is the question that I wanted to address next. So what we did now, and what you usually do with traditional solutions, is that when a request comes to an application, it is assigned a thread, and it uses this thread for the time the request is being handled. This is called blocking programming. So for example, in our case, when we had an add to do call, then a request came to our application, then we called the database, we stopped the thread waiting for the database result to come, then the results came, and then we could return, right? In some cases, we would, for example, call a different service at this point or something like this. So in this model, if you have like 1,000 requests, then like at the same time, then you'll have to have 1,000 threads, most of them blocked. CPU has to switch from thread to thread. Thread has some code costs. One of the alternatives for this solution is non-blocking programming. So and the way Quarkus does it underneath is using an event loop from Vertex. So when a request comes to Quarkus, when a request comes, we can do the computing that we want, and then if we have some I/O operation that we want to do, we can just schedule it, and then do some other work, and then when this work is done, we can continue on this work. Yeah, this way we have much less threads, we have much less switching threads for the CPU, and we are generally faster. So yeah, let's do some non-blocking demo then. I'll just switch my application to using non-blocking stuff from Quarkus. As you can see, usually non-blocking programming is a bit more complex than blocking programming. It's a bit less easy to track, etc. That's why we usually start from blocking code. Quarkus, like in Quarkus, what we use, the reactive programming library that we use is called Mutiny. And like the types, the basic types of Mutiny are uni and multi. And uni is for a singular value that can be null, and multi is for 0 to whatever number of values. This is actually a streaming type. So let's change our code to work with this. So Quarkus recently added a library that's called REST-easy reactive. So to use it, I'll switch to Quarkus REST-easy reactive, and let me start from that actually. So let me do mvn Quarkus test with this. As I don't know if you noticed, I just added this reactive word here, and it should nearly work with this. So I executed mvn Quarkus test, and yeah, let's see what happens. Okay, the tests are being executed, and this should not succeed. Yep, it fails. It fails because the error message should say it all. It's quite long. Anyway, the error message says you have attempted to perform a blocking operation on an IO thread. This is not allowed. So what happened? I have a to-do resource that has the same set of annotations, etc. that it had before. And what I do on an add operation, so now with REST-easy reactive, this method is by default executed on the event loop. So what I'm doing here is I'm calling this repository add method that actually does to-do persist, so a blocking database operation, and I'm doing it on the event loop. So if I was allowed to do it on the event loop, it will result in my application getting stuck. So I cannot do it. Quarkus thankfully has a check for this. So yeah, what we can do is say that this operation is blocking. So we could add a blocking annotation here to allow it, or we could also do a blocking here. And now the test should pass. Yeah, this is passing. That's because with blocking annotation, the user's code from this is offloaded to a different thread that is allowed, that is like especially there for running blocking code. Okay, we made it work. We have REST-easy reactive, but do we really have any gains? I don't know. What I wanted to show you now is also a new add-on to Quarkus. This is, oops, I haven't started it again, sorry. Quarkus dev. If you run your Quarkus application in dev mode, you can go to your host and port /q/dev. This is actually configurable, but this is the default path. And here you'll see dev UI. This is, as is said, only available in the dev mode. And here you can see some details about your application. So, and even links to the guides, for example. And here we have a section for REST-easy reactive. And this section has a list of endpoints, but also has a list of endpoint scores. So our hello endpoint is great, but our, for example, post endpoint is not. That's because it is needs a worker thread dispatch, right? So it's not invoked on the event loop, so it will be slow. So let me now try to address it with another new add-on to the Quarkus universe. So the need for blocking came from Hibernate, actually, right? So I used Hibernate. I couldn't do non-blocking calls. I can switch Hibernate to something else. That's actually still Hibernate, but it's called Hibernate Reactive. But I then need a different driver to the database, so Grpc Client. And with Hibernate Reactive, I still get this Hibernate Reactive Panache add-on. I need to change stuff a bit, so because the way it works is really similar, but not exactly the same. So my entity now extends Panache entity from a different package, and now I have to change the repository a bit. So what I had before was I called to do persist and then return the to do. Now to do persist is a non-blocking operation, so as you can see it returns a uni. So it will return right away, and this will just happen asynchronously, right? I had transactional before on this method. Now I have to replace with panache with transaction, and can do the work I need to do. So I have to the persist, and I cannot do it as I did, like with calling to the persist and then returning to do, because then I wouldn't know if it succeeded or not. So what I need is actually waiting for this to finish and just continuing after it finishes. So I want to do to the persist, and I want to return this actually. I want to return not a to do, but a uni of to do. Oops, yep. Uni of to do. So I will return whatever is returned from this. This to do persist returns a uni of void type. So I will need to do something like this. I will just replace the result with the to do. And actually I can simplify it, right? Okay, so that's all. It's actually probably a bit more complex than we had before, but I think it's still quite simple how we do it in Quarkus. Now I'll quickly change the rest of the things. So I can return a multi of to do, and as it happens, streamall is still a method in reactive hibernate panache, but it returns a multi. And modify, let's just make it panache with transaction. And yeah, find by ID here again will not return a concrete value, so I'll just so what it returns is actually a uni of to do type. So to do and to do. And so with this uni of to do we can actually return it, but before we return it, let's invoke the modification on it. And yes, now we return a uni of to do, and then we can take this all and just go to resource and change it to return a different type. So uni of to do DTO should be returned here, and then we can do repository add oops, and then app to the DTO, right? Oh, sorry. Something like this. I'll just really quickly change the rest. Actually, this gets even shorter than it was, and this gets a bit different because we again have to return a uni. So let's do it this way, and then map with mapper entity to DTO. Something like this. Okay, doesn't compile. Okay, I have alt imports. So let me just do MVN Quarkus dev on it. Okay. It starts the container, hopefully to work. Let's get a bit further. So what I showed you now is Dev UI, which is new in Quarkus, REST is reactive, which is new. It is non-blocking all the way. So every layer is written in a non-blocking fashion, and we also have Hibernate reactive and also Hibernate reactive with Panache. That is also non-blocking. What happened here? It should work. Let's run it here. Anyway, I will hopefully show the test passing. I'll show you the test passing in a moment. So there's one thing I wanted to show you with the code. Sorry, it got a bit long. It's the first time I'm doing this presentation. Didn't know it will take that much. Practice was a bit shorter. So can we be even faster? So for the communication with the web browser, I think it won't be that easy to get any faster. But if we do something else, one of the answers for this question is gRPC. So gRPC is a binary protocol on top of HTTP2. It's based on protocol buffers. It's contract first, so it means that you first define how you want your communication to look like, and then you can go and start coding it. It has a unary call, which is a request response like you have with REST, but also has client side, server side, or even bidirectional streaming. And why should you consider using gRPC? It is faster than REST and still friendly, in my opinion. It uses less bandwidth, less CPU than REST communication with, for example, Jackson. And I think it's good for service-to-service communication or mobile-to-service communication. And it is something that we actually personally, me and Martin, try to make very user-friendly in Quarkus. So this is how a contract for gRPC may look like. So there is a message, and message is a counterpart of Java class, I'd say. Message can have a field or multiple fields. Here we have a field of type string, field of type integer, a collection of booleans, and we can also have a field that is of type of a different message. And there are other stuff like enums or maps. And when we define messages that we want to pass from our services, we can define a service. And such a service may have multiple methods. They are called RPC in the definition file, in the contract, gRPC contract. A method has to have some name, it accepts some parameters and returns, accepts some message and returns some message. This messages could be singular or could be streams. So let me, I hope, quickly show you how it looks in Quarkus. So in Quarkus, you put the proto file, so the definition of the contract definition in src main proto directory, and it should be a file with ending with suffix proto. This is actually protocol buffer stuff. So I have I have written this contract for to-dos that I like to use here, and this is how it looks like. So firstly, I define a syntax to be proto3, by default, gRPC would use Proto 2, which is quite old, doesn't have bindings to that many languages, because even though gRPC is a binary protocol, so not something like JSON where you send the text, it is nearly language agnostic. You can use it with really a lot of languages. And yeah, and with Proto 3 you get support for more languages. Then there is a package here. This package is a gRPC package, not a Java package. This is actually optional. Then a Java package, and this actually, even though it says option in Quarkus, is not optional. You have to specify it, if you don't, Quarkus would fail and will scream at you, use a package. Then I have a service called todos. It has a few methods: add for adding a to-do, mark done to mark a to-do as done, and watch. The add and mark done methods consume a to-do and return void. Watch consumes a void type, which is actually just an empty message, and returns a stream of to-do. So any updates that it will return any updates that happen to our to-dos. To-do has ID, title, description. So this is actually the same what we have in the entity or the to-do, and then there is a state that is new or done. So let me implement this service. I'll call it a to-do service. Oh, I need to start my application. Either build or start my application to have files generated from this to-dos proto. So normally when you use gRPC in your project, in most frameworks, at this point you'd have to add you'd have to add some configuration to your Maven or Gradle project. With Quarkus, it's as simple as just adding a dependency on Quarkus gRPC, and you don't have to add any plugins to compile the proto file, because how it works is a proto file like this is compiled to some Java files, C++ files, whatever language you choose, by a tool called Proto-C. This Proto-C is, in our case, invoked by Quarkus internals if they see Quarkus gRPC among the dependencies. And yeah, so what this Proto-C tool does, it will generate Java classes from the file. We have our own plugin for Proto-C to generate some stuff that we think makes working with gRPC easier. So as you can see in the target, generated sources gRPC, there are sources generated for it. IntelliJ didn't pick it up. I'll just quickly reload the project and it should become aware of this. Yes, it does. So if I want to implement a gRPC service in Quarkus, I can use an interface that we generate and just extend it. So let me do it this way. So I can say that this is my gRPC service and that it implements todos. This is actually the same name as we have here in our proto file. And now when I say it implements todos, I got 3 methods to implement, the same methods that were defined there, but gRPC has this convention of naming methods from a capital letter, and we switch it to a lowercase letter, so because that's how we do it in Java, right? So let me just really quickly try to implement it. Mapper. Well, I will use the mapper again. Repository, and on add, what I like to do is, okay, I'll first enhance my mapper to be aware of gRPC stuff. So mapper, okay, and then I can go back to the to-do service. I can use the mapper to map gRPC stuff to an entity, and then I can just invoke repository add, this is right, add this to do. I also need, but I need to replace the result with void type. I'll make a constant of this void type, void. Okay, so I think this was simple. Let's do something similar for marking as done. So here we can do repository, modify, request, get ID, and then let's take the to do and do to do state is equals done, and again we have to replace it with void. Now, what is the tricky part? So currently we have something that we could do just repository get all here and just map it to with our mapper to gRPC. But then we will just get what's in the database, and that's all. What I'd like to do is to get like if someone subscribes to Watch, I'd like to send him updates on whatever is going on. So I'll alter the repository a bit, and on any update I'll send an event. And let's inject event of type to do. This is actually a CDI thing. So to do, let's call it a to do update maybe. And so whenever I persist a new to do, I will just invoke to do update fire async. So this means I will asynchronously fire an event of type to do. Yeah, basically that's it. So I'll do the same for modify. So with this, I can now get back to my to-do service and have this, and also have something that will produce the events for the new things. So let's do a broadcast processor of to-dos maybe, and let's call it update broadcast. This is a mutiny thing, and this is actually this is a multi that broadcasts all the events that it is given. So with this, I have this events sent, so I can do a method that will observe these events. Watch to-dos maybe, and it will observe asynchronously. It will observe to-do updates, and it will use this broadcast processor. How did I call it? Update broadcast. Update broadcast, and call on next on it. So this method will be invoked anytime someone fires an async to do. Fires a to do event, and it should put this event to the update broadcast. So now I can, instead of just returning the things I have in the database, let's maybe store it in some. Maybe let's do it a bit differently. So now I have get all. I can do return a multi that is created by concatenating the database results. So repository get all and the broadcast update broadcast. And now I'll just map it to entity to gRPC with entity to gRPC. Now something is wrong here. What is wrong here? Repository get all is a multi of to do, and this one is multi of to do. What is wrong here? Why are you complaining? concatenating. Oh, sorry, concatenating. Mutiny tries to be very descriptive in what it's doing. So it's also, the idea is not to have millions of methods for every reactive operation here. So you can create a multi, so multi create by concatenating, and then you have to say concatenating what, so concatenating streams. So let's save it. Okay, let me get back to a Quarkus dev mode for a moment with this. Sorry, get dev UI. So we have the dev UI here, and the dev UI now with the Grpc extension got a new tile on the UI. This tile is called Grpc. You can click services here, and here we have a health endpoint that is exposed, and we also have our to-do service. So if we go to a to-do service, we can test our to-do service manually from the browser. So let's try to add a to-do and see if it works. I can also do a second screen, so second browser window with the UI, and we'll see if it really works. So let me add a cat here. Feed the cat. Okay, it's added. So I'll start watching for the to-dos. So if when I clicked watch, I see that there was a feed the cat to-do already there. Sorry for the size of letters. I don't know if I can make it bigger and still make it fit this. Maybe that's a bit better. Let's add a to-do to walk the dog. Okay, so I added a to-do to walk the dog. It appeared here on the watch. It also appeared here. If I mark a cat as done, it appears here in the stream. So it works. There's one last thing that I'd like to show you with Grpc, how awesome Grpc support for Quarkus is. So REST is great because it has a lot of tools. It's simple. You can call it, see the text that is sent back and forth. You can do curl, for example. With Grpc, there's a tool called grp curl, and so you can add, for example, add to-dos with this. But this tool requires being installed to the system, etc. We have this dev UI to help with it. But what also makes REST a good choice usually is the ease of testing. So we, for example, have a REST assured library to test it. I don't know of any library like this for Grpc, but with Quarkus we can do something different. So let me really quickly add a to-do service test, and it will be a Quarkus test again. So with Quarkus, so when you compile a protofile that is a contract definition for Grpc, there are two things that are being generated. So there are things that allow you to expose a Grpc service, but also things that allow you to consume a Grpc service. And we use this. We saw an opportunity in this. So now in Quarkus, you can inject a Grpc client. For example, using the interface that we have generated and used for the service as well. But you can also use a different Grpc stubs that come directly from Grpc Java. And yeah, so let's call the client. So this client, normally you'd have to configure the host and port for the client to use. But with Quarkus, if Quarkus sees a client that is injected and is not configured, then it will assume this client is created to test the gRPC service that you expose. So it will just configure it to your gRPC host and port. Let me just quickly try to show that it really works. So let's annotate it with test, and let's do client add. So with gRPC, what you get generated for the request and response types is it's builder based. So you have to do something like this. So let's set title to, I don't know, laundry, and set the description to pack the washing machine, and let's send it. Okay, and now let's put something like this here. I will explain in a minute. Okay, and then client watch. So yeah, we pass a void here. What gets returned is a multi, and on it multi we need to subscribe to it with something that will collect something. So let's collect maybe to-do titles. To-do titles. Let's do some thread safe list, and let's subscribe with to-do titles, add to-do get title. And now let's await. Let's await at most maybe 5 seconds until the to-do titles list contains, what was the to-do again? Laundry. Okay. I'll run it from the IDE. Should work. Again, you can see the container starting for the dev services. And it passed. Now, I told you that I will explain myself from this, await at most. So when you do client add, so the thing with this reactive library that we use, Mutiny, is that everything is lazy in it. So if I do just client add, it would return a uni, but it wouldn't do anything until I subscribe to it. So I could do subscribe with something, or I could do await something. Doesn't make a difference in terms of it being executed. Of course, it makes a difference in terms of what it does. But yeah, that's why I cheated and did await at most here. Okay, that's actually all I want to show you on my demo. There's a short recap here. So what's new here is the no config gRPC client for tests, testing gRPC from the dev UI, and what I think is really great in our gRPC support is the integrated code generation from protofiles. So it's like with Java in the Quarkus mode. If you run Quarkus, you can alter any Java code, you can add classes, add methods, remove methods, and without your any action, Quarkus will figure out the changes that were made, would apply them, and it would restart itself on your next request with the changes applied. And Quarkus is really fast, so it's not really noticeable. It's not something that will hurt your work. And with gRPC, we are providing the same experience with modifying the protofiles. So whenever you modify a protofile, the changes you did will trigger our code generation mechanism, and it will recreate the Java classes from the proto file that was modified, and you can right away use it from your Java code. Like the only factor that slows it down, because it's really fast, the only thing that slows it down is the IDE is not does not watch the generated sources that closely, so sometimes it takes a bit of time for the IDE to be aware that these files changed. Okay. So
Alrighty then. Yeah, thank you very much. I think that either you or Martin took a great deal of answering all of questions in our chat. I think that there's one I saw that was not yet fully answered. Maybe you know the answer to that one from Michał Robicki about this continuous testing feature. If he asks whether you use test containers underneath.
I don't know that. Martin, do you know?
No, I have no idea.
Yeah, that was the one that Martin didn't know.
We use test containers heavily for integration tests in the Quarkus repository, but whether we use it for the dev services or not, I don't know.
All right. There was a question in Polish, and I know that you guys, Michał and Martin, you are quite biased, but I think that's still a valid question nonetheless. What's the better thing to start with as a framework, Quarkus or Spring? I know
it's the answer is like when you get over 30 or 30 something, the answer is always it depends.
Yeah, that's true. That's true developers answer all the questions apply.
If you are after productivity, Quarkus is a better choice. If you are after performance, Quarkus is a better choice. If you are after a bigger user base and more stability, Spring Boot is probably a better choice, right? With stability, I think we are still quite good. We even provide a supported version of Quarkus. So supported means that we provide a product based on Quarkus. So for the things that we say that are stable, I think they're quite stable. But still, Spring Boot has been there for many years. Or maybe Spring Boot not for that many, but Spring itself, and Spring Boot for some years longer than Quarkus definitely, and it has a bigger user base. So
yeah. Maybe I just wanted to add that you can actually try to use Spring APIs running on top of Quarkus. So that's also a possibility. You can just try Quarkus even using the Spring APIs. I mean, Spring DI and Spring Web Controllers and so on. Basic APIs are supported. So.
Yeah, so many companies already use Quarkus in production. I even have friends in Toruń who have other companies have Quarkus services in production. Some companies report vast cost efficiency improvements thanks to switching to Quarkus. I think developer experience is much better in Quarkus. So yeah, it's definitely worth considering.
All right, that's your look on the topic. I think that's better than I expected. I thought that you would just do the marketing on Quarkus, but we have another question from Michał Kudła about why Quarkus don't use Jakarta E namespace and other following on how much it differs from Jakarta E.
Yeah, so I can try to answer. So the first one is why Quarkus doesn't use Jakarta E namespace. Well, it's really difficult to answer this, but the main point is that it's really tricky to get the support of Jakarta E. And I'm not sure whether Michał is talking about Jakarta E, the package renaming, or the Jakarta EE group artifact and version coordinates. So we use Jakarta E coordinates, but we are still waiting for the other part, which is switching to the new Jakarta E packages. Because once we switch, then we will have to switch all the tools, all the APIs we use. That's definitely a breaking change. So it's not so easy. Like there are some strategies how to avoid breaking user apps, but it's definitely a tricky question. So we're still waiting. Because even the big players, the application servers are also not fully supporting this stuff. So, and how much it differs from the Jakarta EE? So Quarkus, I try to answer this in the comments. So Quarkus is using, or includes a lot of Jakarta E APIs. Including JAX-RS, JPA, CDI, and so on. But we're not a certified application server, of course. So, for example, we don't run the full TCKs, which is a set of tests that every application server needs to pass in order to be certified. On the other hand, we are more, we are implementing microprofile, which is something a bit different, and we run on all the microprofile TCKs, so it's a bit different. But we can say that in most areas we do try to cover all the important parts, but like I said, we don't test everything according to the specs. So, for example, the CDI implementation we have is inherently different because Quarkus is heavily build-time oriented, whereas the CDI itself is a runtime dependency injection. So what we do is that we support most of the relevant features, but there are obviously some features that cannot be implemented in Quarkus.
I hope that that fully answers the question of Michał. If not, please add another question to our chat. And we have another question from Krzysztof Suszyński. And Chris asks, is there any push to upgrade the CDI in Quarkus to support multiple configurable context similar to Spring?
So to be honest, I'm not completely sure what multiple configurable context actually means. Michał, do you know? Do you have an idea?
Maybe something like Spring profiles. I don't know.
I would think that that's about profiles, but Krzysztof, if you can broaden your question, if it's indeed profiles you have in mind, please do. And in the meantime, we have a question from Michał Borowicki, so let's go to that. Does Quarkus provide similar API to Spring's bin factory to generate bins dynamically based on properties?
So first of all, like I said, Quarkus is build-time oriented, which means that the set of all the beans that are used in your application must be known during the build. You cannot add a bean at runtime. Well, that's the main difference. But it was a design choice because we wanted to switch to the build-time oriented stack, and this allows for amazing optimizations we can do. And Spring's bean factory to generate beans dynamically on properties. Well, you can, in theory, you can build your beans based on some properties files, but the thing is that this properties file will have to be known and ready at build time. So we don't have this functionality out of the box, but you can implement your own extension.
But I think that that's the Quarkus is built driven, bill oriented is answering the question the best. So actually explains why we don't have such a functionality. Another question is coming. Michał Kudła, does test reloading also work with integration testing?
What does it mean integration testing? So for me, testing that talk to the database, tests that talk to the database are a kind of integration tests already. So for this it does, but Martin, do you understand the question better? Maybe.
So I wanted to ask what test reloading actually means.
I think it's about continuous testing.
I think so. Yeah.
Also integration testing. So basically, we can answer that. So far, you can only use the continuous testing standalone. Michał showed this with a special command like Maven Quarkus test, or integrate it in the dev mode. You cannot, I don't know, integrate somehow with integration testing. And I have no idea.
Okay. If you had something other in mind, Michał Kudła, the one who asked the question, please do provide us some more details about what you meant with integration testing, other than that what Michał already presented. Another question from Michał, and I don't quite get it, so I just read it. Can I use somehow Quarkus API to generate that code during compilation?
So I think to generate some code during compilation, you'd need to write a Quarkus extension. So it's not it's actually something entirely possible and something we encourage you to, but I don't think you can generate code from your so what the user code in a Quarkus application does is usually the runtime code, right, Martin? I'm not lying, am I?
I'm wondering what this Quarkus API actually means. So Quarkus extensions, they do generate a lot of code. Basically, we generate the bytecode, not the source classes. Instead we generate the bytecode, but that's about the bean factory replacement IDD command. You will need a Quarkus extension for this. We have some APIs for this, like synthetic beans and so on, but you will need a Quarkus extension, which is actually some code that has two parts. One part is used during the build phase, and in this phase you can register your own beans based on the bean attributes like bean class and so on, the scope and so on. But
Michał, sorry to interrupt, but Michał, this question is about the bean factory replacement that he asked. All right.
So yes, it's possible, but you will need a Quarkus extension, and the part that is used during the build phase can register beans based on whatever you can imagine.
All right. I don't see that Krzysztof added some more details about the question about this configurable context. I do think that he meant Spring profiles. So if that's something that you are planning to provide in introducing Quarkus, so do you have something like that?
So is it applied to tests, or is it like multiple?
Not only. So if I remember correctly, then it was more than 5 years ago when I worked with this stuff. In Spring, you can say that this bean belongs to profile. To one profile, and another bean belongs to another profile, and then you can when you start your application, you can say I want this profile, and this bean will be picked up, and the other bean won't be.
Beans configuration and many more things.
So in Quarkus we have something similar, but it works a little bit differently because we, like I said, we are build time oriented. So you can specify your profiles and then add your beans only for the specific profile. But then you have to build your application, and when you build your application, you choose the profile that is used. So you can have like multiple beans in your application source code, but then it depends on the profile that is used to build your application, and only the beans that should be used in the specific profile are added to your application. But you can
totally makes sense that we want to build only the necessaries. Okay. Last call for your question, guys. On the other side of the screens, I can't see anything coming, but maybe if you have last questions, please do ask them now. And in the meantime, I think that maybe you have some final words because I can see that you do, Michał. So please.
Yeah, I have some final slides. So Quarkus is open. It is an initiative started by Red Hat, but we are very open. This is actually our motto, Red Hat's motto, to do everything open source that we can. And we already have more than nearly 500 code contributors for Quarkus. And you are welcome to contribute to Quarkus as well, or create your extensions. And if you have any problems with Quarkus or you have some feature ideas for Quarkus, GitHub issues are also open, and these are very welcome. Recently we created something called Quarkiverse Hub. So if you have a Quarkus extension, you're working on Quarkus extension, you can put it in the Quarkiverse Hub, and then it should be included in some CI ecosystem, so it should be tested then. So we should help you with testing it, and it should be visible for other users, more visible for other users, your extension. Yeah.
If I'm not mistaken, we also have a separate BOM for Quarkiverse so that users can consume your extensions easily.
Mm-hmm. Okay, now I have a few links. That's the last slide I have. So Quarkus project website is quarkus.io. You can catch us on quarkus.io zulipchat.com. And there's a chat for users that is like really noisy. A lot of users there that can help, and the Quarkus team are also there to help. Quarkus.io on Twitter. If you are from a different JUG and would like to invite us, like Quarkus World Tour, you invite Quarkus World Tour to your JUG, then email worldtour@quarkus.io. Okay, and there's some book. A free book on Quarkus that is.
Oh, that's important information. That is a free one.
Yeah, that you can download on this link here.
Okay, I cannot see any more questions, but there was plenty of questions today. So thank you very much, all our watchers today, that you have been very active. Thank you for that, because that's what makes those meetups very, very special. Your questions. So I think I'll just check once more, but I think Michał Rowicki and Michał Kudła, and it's not like Martin. It's not like every person in Poland is named Michał. That's a coincidence. But you guys were the most active ones, so please drop us a message on leaders@warszawa.jug.pl. I put it on the comment. I just made it some Ponglish, so sorry for that. Okay, come on. Okay, and that's for Michał Kudła and Michał Rowicki once again. And I would like to thank you very much, guys, for being with us today. There was great presentation, plenty of information, plenty of questions. I hope that you are as satisfied as as I am, because I really am. And I hope that we'll see each other in the future, possibly in person, not online. We try to do those meetups offline
great. Yeah.
once again. So you guys are more than invited to come to Warsaw. And thank you very much once again. And thank you everybody for being with us today. Good evening, good night.
Thank you for having us.
Thanks. Bye.
Bye.